So what is this binomial theorem, right? So the actual binomial theorem is this. It's the coefficients, right? Coefficients of a binomial expansion, right? And it's how we actually find the coefficient. So the coefficients of a binomial expansion are called binomial coefficients. Very unique, I know. And the theorem is how we find them, right? So how do we actually find these coefficients? So let's take, for example, the expansion of this binomial, x plus y to the power of n. So we can't necessarily use Pascal's triangle to figure that out because I actually don't know what my exponent is. I do know that I will have one more term than I have exponent. So if this was, say, 10, I know I'll have 11 terms, right? So in the binomial expansion, this in the basic term is going to look like this. X will always be to the power of n, right? Always the highest degree. And then you'll notice that your first coefficient is always the n value. And x, or your first term, is always n minus 1. And your y is just 1. We have a lot of things happening in between. We don't necessarily know what's happening in between. But one of those terms, I'm going to write it in a different color, it's going to look like this, NCR. So this actually stands for a formula that we're going to use in just a second. Your X will be whatever your N is minus that R value. And your Y value will be your R statement. Because again, if you add these together, you will get N. So N minus R plus R, the R's will cancel away. And then if I continue, all right, I'll have an N again. My X will just be an X. My Y will be N minus 1. And then my last term will be Y to the power of N. So if we take a look at our last example, maybe not this one. Let's look at this one. So notice there was no number in front of our x squareds and our y squareds, and so our numbers happen to be just 4, 6, 4, and 1. So basically, we're gonna try to find the coefficient of one of our terms without actually using our binomial expansion. That's the goal in this theorem. So I said NCR meant something. So let's figure out what that is. So NCR is this. It stands for n factorial, right, all over n minus r factorial times r factorial. So we've already talked about what a factorial is. Instead of NCR, this symbol you will also use, so you can make a little note. So the n and r, so n and r are just numbers. So this is often used instead of NCR. Okay. And C just stands for combinations, which we'll get into a little bit more in 8.6. Okay, so the first thing that we want to do is, how can I use this information? So, so let's first talk about these examples. So these examples will follow the same direction. We want to find the binomial coefficient. All right, so here's our first example. It's going to see 9C2. So if I use this formula, so I might want to jot this down. So n is our first number, so our first number is 9. So this will say 9 factorial. And then if we think about it, n minus r, so 9 minus 2 is going to give me 7 factorial. And then my r factorial, which is 2. With this, if you ever add the two numbers together, 7 plus 2, you'll get the 9. We don't want to necessarily do that, but it's just kind of a little check, fact check. Okay, the largest factorial on the bottom is a 7. So I'm going to expand the 9 factorial until I get to 7. And so 7 would be 7, 6, 5, 4, 3, 2, 1. I don't necessarily want to write out those numbers because that's a waste of my time. So I know the 7 factorial and 7 factorial will eventually cross out. So I'll just write that out. So let's cross things out. 7 crosses off with 7. The 2 will cross off with the 8, leaving you with the 4. The 1 really makes no difference, right? 1's not going to change anything. So 9 times 4 is going to leave me with 36. So that would be my coefficient. And this would actually be my coefficient for the third term. Okay? So this would be your third term. Okay, because we would start off with 0. R is equal to 0 would be our first term. 1 would be our second term, so third would be, so 2 would be our third term. So that can be kind of confusing a little bit. All right, let's try another one. What happens if I say, I write it like this, 11 and 4. So again, 11 is our n value. This number will always be larger. So 11 factorial. 11 minus 4 will give me 7 factorial, and then 4 factorial. Again, 7 factorial is my larger one. So 11 times 10 times 9 times 8 times 7 factorial. 7 factorial. 4 times 3 times 2 times 1. So first things first, I'm going to cross off the 7 and the 7. Next thing I'm going to do it in green so we can see it. 4 times 2 is going to give me 8. So I'm going to cross off 8 all the way over there. And then last but not least, the 3 will cross off with part of that 9. All right, so everything in your denominator should cross off. So I'll have 11 times 10 times 3, which should be 330. So this would be the coefficient of the fifth term. Okay, so why is this the fifth term, right? Why was this the third term? So how we can actually use binomial expansion. So how to use your binomial theorem to expand. That's what we're going to do. So we're going to expand this one. We're going to say x plus 1 cubed. Okay, so I already know that I could make Pascal's triangle, but I'm trying to not do this. So technically, binomial coefficients are going to look like this. So binomial coefficients. I have a power of 3, so that's 3. C, and my first r will be a power of 0. Okay? And then I'm just going to keep adding from 0 until I get to 3. So notice I have 1, 2, 3, 4 terms, right? And which we already talked about is I will have always one more term than I have exponents. Okay? So how do I actually use this? So 3c 0. So 3 factorial all over 3 minus 0 is just 3 factorial and 0 factorial. Remember that 0 factorial is equal to 1. So this is just going to cross off with that and will equal 1. 3c1 will equal this. So 3 factorial, 3 minus 1 is 2 factorial times 1 factorial. So 3 times 2 times 1, 2 times 1 times 1. Again, stuff to cross off. We can basically cross all of that with all of that. You are equal to 3. 3c2. So 3 factorial. 3 minus 2 is 1 factorial, 2 factorial. So 3 times 1 times 1, 2 times 1 times 1 again. All of that disappear. You're left with 3. And then 3c3. 3 factorial, 0 factorial, 3 factorial. So notice that's one of the reasons why there is symmetry is because all we're doing is we're switching kind of the 0 factorial and 3 factorial around. So everything will cross off. Again, 0 factorial is equal to 1. So if we use our binomial expansion, right, we're dealing with x, we're dealing with 1, and now these are our coefficients. So in reality, you have a 1, and then x cubed, and then 1 to the power of 0. And this will be plus 3, and then x squared times 1 to the power of 1. And then 3, and then x, and 1 squared, and then 1, and then 1 cubed. So all of this is just going to be x cubed plus 3x squared plus 3x and then plus 1. So this will always get your coefficients, and then you use your knowledge that you are n minus r and r value to continue. So if I use that information to figure out what my actual value would be, let's go back to this example. So I said that this was my third term. Okay, so 36 would be my coefficient, right? And let's just pretend that all of this was just x plus y, right? And then to the power of n, whatever that was. So it says n minus r. So n minus r, so this would be n to the power of 7, or sorry, not n, my bad. This would be x to the power of 7. And we know that all your exponents need to add up to that other value, so that would just be 2. Okay, and again, we would start at power of 9. So 9 is your first term, 8 would be your second term, 7 would be your third term. So this would be our entire, not just your binomial coefficient, but this would be your binomial term for this expansion. Okay, so this is how we would use it for binomial expansion. The power of 3, if I was really expanding this trinomial, or not, sorry, this binomial, my bad, I would use Pascal's triangle. So I would come back to this and I would expand it using this. The binomial theorem, I would use this more to say what is the third term. Okay, so one more problem. Let's do this. So let's say what is the, let's say, fourth term in x minus 1 to the power of 7, right? So let's make this up as we go. Okay, so let's use our n and our NCR. So fourth term, so NCR, and then this will be x to the power of 7. Okay, minus 3, because that will be our n is really 7c3, and then this will be to the power of 4, and then y to the power of 3, right? Because if it was our fourth term, x to the power of 7 would be our first term, x to the power of 6 would be our second term, fifth would be our third term, and so power of 4. So this is our binomial coefficient. So I need to use my equation. So this will be 7 factorial all over 7 minus 3 factorial, which is 4 factorial, and 3 factorial. So 7 times 6 times 5 times 4 factorial, all over 4 factorial times 3 times 2 times 1. 4 and the 4 will cancel out. 3, 2, 1 cancels out with 6. We are left with 35. So 35 x to the power of 4 y cubed would be, would be our problem to start off with. Instead of y, we're going to plug it in with -1 because it's not really a y, and -1 to the power of 3 stays negative. So your fourth term should be -35 x to the power of 4.